Hi everybody. Sorry to have to talk to you under this kind of circumstances, but sometimes these things happen. Just want everybody to know that I'm going to do everything I possibly can to make sure I'm available and to make sure that you have the resources to prepare. Hopefully this is all just a one-day thing, but if not, I plan to put up video lessons. I will always be at school, so if you ever need to come out and work with me, you definitely can. I worked with a few people today. I will do everything I possibly can to make sure you are prepared for the AP exam. Basically, today I'm going to talk a little bit about what we would have done in class. I will also try to be around at school at least a little bit into the afternoon to be available for anybody who does have questions. The section that we were planning to do today was really kind of a combination of section 10.4 and 10.5. Both of those sections are essentially a continuation of the max-min problems that we did back in, that we did a little bit back in chapter 8, kind of building on that idea, kind of pulling things together from the perspective of the AP exam. I'm really going to be merging those two sections. We're not going to be doing a lot of problems out of those sections because I don't think they're really that in line with the AP exam, but the concepts are really important, and so that's what I'm going to be looking at today. The big thing that I need you to understand is this. If I have a function and I want to find relative extrema, that's a term that will be used on the AP exam, extreme values, maximum values, minimum values. There are a couple different places that those relative extrema can take place, and you need to be aware of all of the possibilities, not just some of the possibilities. So for example here, if I have a function, hopefully at this point everybody knows, relative maximum and minimum values occur on a function where the derivative is equal to 0, okay, where you've got a horizontal tangent line, okay? Now, you need to be very careful because just because you get a derivative that's 0 doesn't necessarily mean that you have a relative maximum or minimum. You could have a plateau point where a graph kind of levels out and then it continues upward. And you might not have a relative maximum or minimum. So you do need to watch for that. And that's part of the reason that I emphasize the idea of drawing the number lines where you find the places where the derivative is 0. Remember, those are called critical values. And then you can test points on either side to find out if the derivative is positive or negative. So for example here, if this is function f prime would be changing from positive to negative on either side of your number line where that derivative is 0, and that would tell you you have a relative maximum value. Okay? Now, one of the things we're going to be asked a lot, both in these sections and on the AP exam, is to find maximum or minimum values of the function, specifically absolute maximum or minimum values of the function. And this is where you need to be very careful. If they ask you for an absolute maximum or an absolute minimum, sometimes it's called a global maximum or a global minimum, they want the highest value of the function on the particular interval that they're having you look at, okay? Remember that the value of a function is a y value. How high does the function go or how low does the function go, okay? And you need to be careful because it's possible that a relative maximum or minimum point, a turning point on your graph, could be the location of the highest y value. However, it's also possible if you have an interval that ends, it's possible that your function was going up forever and it's getting cut off. It's possible that you have a maximum value at a point where the function didn't change directions, but just the interval got cut off. So you need to check the endpoints. If they say the interval goes between, an x value of 0 and 5, you need to check f of 5 and you need to find out, is that higher than this relative maximum over here? It may be, it may not be. That point could be down here somewhere and it could actually be lower than that point, and then that would be the absolute maximum. But we have to check endpoints and places where the derivative is equal to 0, or undefined actually, because you could have a cusp. Okay, so that's going to be the primary concept that we're focusing on, and I'm going to turn off the camera now and I'm going to switch over to an actual problem to show you how this might look on the AP exam.
Alright, here's the problem we're going to be taking a look at. So we've got Amazon testing a new drone, and we're given the function of its height in meters. Actually, it doesn't note that it's any particular units, but probably going to be meters. We'll say it's in meters. After a certain number of seconds have passed. And the first part of the question asks me to find the x-coordinates of all the relative extrema for the function on the interval from 0 to 3. Okay, so I have gone ahead and graphed this. By the way, my window here, if you're wondering what window settings I'm using, -5 to 5 on the x-axis, and I'm going from -10 to 20 on the y-axis. And so, anyway, if I graph this, we're going to see that the function looks like this. Okay, so we're looking for relative minimum and relative maximum values. Now, of course, if you look at this graph, it's pretty easy to see where these points are, right there, and a relative minimum right there. But on the AP exam, they're going to expect justification. They're going to expect us to justify where we're finding those values. So really, I'm going to be starting out with my function here. I've got h of t is a little bit closer there. T to the 4th minus 5t cubed plus 5t squared plus 5t plus 2. Remember that the relative extrema are going to happen where the derivative is 0 or undefined. So you need to show that you're taking the derivative of that function and you're setting it equal to 0. So I'm going to get 4t cubed minus 15t squared plus 10t plus 5. Okay? And then I need to put this into my graphing calculator. Probably would have been a good idea if I'd already done that, but live and learn. Anyway, so we've got the 4t cubed minus 15t squared plus 10t plus 5. Now keep in mind the units on the graph may not need to be the same as the original function. It's very possible that it may not increase or decrease nearly as much, so I think I'm going to change my window settings here. I think I'm just going to have the y go from -5 to +5, and let's see what ends up happening there. So remember, we're looking for places where the derivative function, and we have a third degree function that's the derivative of my first degree function. We're looking for the places where the derivative is 0. Okay? Remember that when you solve an equation, if you're on the non-calculator part, you can factor it and solve, or use the quadratic formula or something like that. Of course, this is a cubic. Quadratic formula is not going to work here. Remember that you have the 0 function option on your calculator, and so you should be able to go to second and hit the second calc button there and get the 0 option. And basically you can just scroll to those different locations where you have those different zeros. And so it's going to ask me to pick a point to the left. I'll click on that. It's going to ask me to pick a point to the right. I'll click on that. And we have 1 0 occurring at approximately 1.4690934. We have another one happening. Let's try this again. So I'll hit second, I'll hit the calc button, I'll go back to the 0 function. We'll go over here to the left of the point, click, go to the right, click. Again, you can just hit enter on the guess, and that other t value is going to be approximately 2.607252. Okay, so those are the two places where you have zeros of your original function. Okay. So we've taken care of that first part. Okay, those are our two answers. Again, those really should be seconds. I should probably put units with those. Now, the second part of the question. The second part asks for the absolute maximum on the interval and the absolute minimum. Okay. Again, if you remember, this function was doing something kind of like this. I think it was coming in and it was doing this and it was going back up. I don't know, something like that. Yeah, it's not exactly what it was doing. But anyway, it's doing that kind of thing. Anyway, the main point here is I need to check any of the places where there was a relative minimum or relative maximum. I also need to check the endpoints because it's possible that the endpoints could be the highest or lowest values. All right, I put this back in my calculator so you can see my graph. I've returned to the original function. So to find the overall maximum and minimum values, remember we're looking for y values. Okay, so on that interval between 0 and 3, I really need to look at this starting point here. I need to look at this functional value over here at 3, and then I need to check these values in here and see which are the highest points and which are the lowest points. Again, it could be the endpoints of the interval. It could be the places where I have relative maximums and minimums. Okay, so anyway, so I'm going to check 3 different points here. I'm going to check the endpoints 0 and 3 and figure out the height. And I'm also going to check the zeros, the places where the derivatives were 0 at approximately 1.469 and approximately 2.607. It would be better if I was a little bit more accurate and put in more extensive decimals there, but anyway, I think that'll get us close enough for this. So I'm going to use my table here to evaluate this. I do have the original function back in. Remember, we're looking for the maximum and minimum values, the y values of the original function. Okay, so I have the original function back in the calculator. I'm going to go to my table, and I'm going to put my table in ask mode for the independent variable, and that'll let me type in whatever x values I want on the table since we've got those decimals. So I'm going to go over to my table now. We want to see what the functional value is at 0. Functional value is 2 at 0. We want to know what it is at about 1.4690934. Okay, functional value is about 8.9 there. We want to know what the functional value is at the relative max or min point at 2.607252. And then finally, we want to check the other endpoint at 3 and figure out what that functional value is. Okay, so there's my table. And hopefully you can see the maximum value of the function, the highest y value is actually the 8.9414. The lowest value of the function is 2. So if they just ask you for absolute maximum and absolute minimum, the max is that 8.9414, the minimum is 2. If they ask you for the points, then it would be the minimum occurs at the point 0, 2 on the function. The max happens at 1.4691, 8.9414. But that's the kind of thing that you're doing. So remember, maximum or minimum value is the highest x or y value for the function. So you do have to check any relative maximums or minimums, and you have to check endpoints.